Okay, so this is going to be a little bit of a mini lesson to go along with the lesson two, which is when we talked about current. So this is going to be talking about wire gauges, and that's also how the size of the wire is referred to and what they're used for. So first off, there are two different kinds of wires. There's solid and stranded. So solid wire, it's cheaper, but if bent repeatedly, it can break. It become brittle. Stranded wire is made up of several smaller wires twisted together, and you can see right here. It's more expensive, but it's much more flexible. So any kind of cord that has to be, plugged in and taken out and moved around, it's going to be made of stranded conductor. Wire gauges and ampacity. So that's how many amps it can carry safely. So first up, we have that's pronounced those four zeros. That's quadruple aught. Okay, so this is the kind of stuff that is coming from a telephone pole into your house. So it needs to be able to handle lots and lots of current. Okay, so can handle up to 195 amps. So that's enough to power your entire home. Okay, just zero or just single aught gauge wire. Okay, those are you'd find those in like your car battery terminals. Okay, so remember car batteries, they're low voltage, but they have to supply a lot of current. So that's why we have to use uh, that size wire. 2 gauge you would find in some welding cables. So if you have a welder at home, most likely the wires that come out of the welder that you use to weld, those will be around 2 gauge. It could be a little bit more, could be a little bit less. Okay, so 4 gauge wire, they're used for things like large electric heaters. So these are things that need to heat up a lot of air very quickly and require a lot of power. Okay, next, 6. So as I said in the other video, ovens and that kind of thing have their own circuit, okay, and they need special wire. So regular household wire wouldn't be enough to power those. So they use around 6 gauge. And most of these things that I'm telling you, it could be a slightly higher, could be slightly lower, depending on the model and brand that you have. If you have a central air conditioner or something like that, they would probably use around 8 gauge wire. So again, this is still kind of specialty wire if you go to the store and buy it. Okay, at 10 gauge, um, this is the point where you can start finding wire at reasonable prices. It's kind of standard. Things like electric water heaters would use 10 gauge wire. 12 and the next one, 14, are probably the two most common size wires in a home. So, so if you have a circuit that requires 20 amps, okay, you would have to use 12 gauge wire, okay, in order to supply that safely. So outlets and lighting, and 14 gauge wire. So again, it's still used for outlets and lighting, but it can only supply 15 amps. So if you have a circuit breaker that's just 15 amps, you could use 14 gauge wire. If you have a circuit breaker that's 20 amps, you'd have to use 12 gauge. Okay, 16 gauge wire is what you'd find in extension cords. Okay, and I should say that the 12 and 14 gauge wire, okay, that's in the walls of your home, it's almost always solid because it doesn't really have to move. Things like a um, extension cord definitely does have to move and bend, so that would be used. That would be using stranded. Okay, 18 gauge, things like lamp cords. Okay, so it's a single light. It doesn't have to provide a lot of current. 20, things that even require less current than that. So you could think of things like an alarm clock or any kind of small electronic device. And the numbers go beyond this. So it goes 22, 24, 26, 28, 30, and even beyond that. So the way that gauges work is the higher the number, the smaller the actual wire is. The lower the number, the larger it is. Okay, so all these numbers are well and good, but let's take a look at some actual wires. Okay, so let's go on over the table. Okay, so here we are at the table, and we have some wires here. So I'll start with the largest. So this right here is actually 00 or double aught gauge wire, and you can see it's about ½ an inch in diameter. And this would be what's coming into your home. So there would actually be two of these wrapped up, going from the telephone pole all the way to your circuit breaker box or fuse box. And you can see that it is stranded, because if it wasn't, this would be almost impossible to bend. Okay, here we have 2 gauge wire. So this is something that would go to something that, like a electric furnace. So again, you can see it's stranded, and even though both of these aren't really going to be bent that much, electric furnace isn't going anywhere, they still are stranded, just because otherwise bending it would be a real pain. Okay, so here we have some 6 gauge wire, and this would be used for things like an oven. And you might notice that this one actually has 3 different wires, really. There's this black one, this white one, and then this bare copper one. And that's because with these, the power would come in through the black, would go out through the white, and this would be the ground. So that's why I said, there'd be 2 of these in the line coming into your house, and there would be 2 of these in whatever cord goes to an electric furnace. Okay, so now we're at 12 gauge wire. Okay, so we can see here that there's actually 4 conductors. Okay, and that's because this one is actually meant for like a 3-way switch. That's why it has the extra red wire there. And all of these now are solid. Okay, they're not stranded anymore. And that's because this is the wire that would be in your walls. So going to outlets, going to light switches, and since it's in the walls, okay, it's not going to move, so it's not going to be bent this way and that way. And with the wire being this small, we don't have to worry about just bending it normally, when we're installing. Okay, here we have a lamp cord. So this is actually a 16 gauge wire. You can see that there are 2 conductors, and if you look closely, you can actually see that these are stranded. And that's because with a lamp cord, it's going to be moved around probably, and it needs to be flexible and not break every time it's moved. Now, I wasn't able to get any wires in like the 20 to 28 gauge range, but I have a wire here. This is actually a 30 gauge wire, and you can just kind of see it there. And this is the kind of wire that we would be using for our electronic signs. Because those use very, very, very low current, so we don't really need anything too thick. Okay, so now you have kind of an idea of what the wires look like. I want to do a little bit of a scavenger hunt. So all of us know what a regular outlet looks like. Okay, and that kind of outlet is actually rated for 120 volts and 15 amps. Okay, and there is a whole range of different outlets. What I'd like you to try to do is try to think of something that you think would have a different outlet. So that could be something that needs more voltage. So if something is 240 volts, or if something needs more current. So I don't want you to go around unplugging things. Okay, ask your mom or dad if they know of any other outlet, so that they can unplug something, so you can take a picture of it. So let's see how many of these that we can actually find, and if you take a picture, upload it to this assignment, and I'll combine them all together and make a big document that we can all see. Okay,